So as we discussed in class, our new unit is going to be focused on solving single variable equations. We will be starting out with solving one-step equations, which should look very familiar to you. And for that matter, even when we get into two-step equations, I think you have all had experience with solving two-step equations from your math class last year. But to start with, what we want to do is understand what the value is of checking our solutions. Now, I know that many of you with your teachers last year were forced to basically treat the check as its own individual step. And I understand the collective moan if you would think that would turn into twice the work, because you would not only be solving the equation, but then you'd have to show the work for checking your solution. So we'll talk more about the need for doing that, but for now, I do want you to understand that by checking your solution, you can basically put your stamp of approval on your final answer and have much more confidence that you've solved the equation correctly. So today's lesson is simply going to be on testing potential solutions for a given equation. So if you recall in class today, we talked about order of operations, and that's going to be a critical component for us to test solutions to equations, because once we substitute a value in for a given variable, once we substitute a value in for the variable, we're going to need to use GEMDAS or PEMDAS, as you might know it, order of operations, to check if the equation is in balance. And this third step here, where it says if you don't get a true result, to go back and try doing a couple things, that's not going to be as necessary for now, okay? All that we're going to focus on today is given an equation, like w minus 4 equals negative 6, and given a potential value for w of negative 10, just running it through the first two steps. So first substituting in for w, and then using order of operations to see if we get a true result or not. And that's where we'll leave things. So this may sound more painful than what it is. So first step is, I always like to start by rewriting the equation, w minus 4 equals negative 6. And what I'm going to do is to take that value of negative 10, and I'm simply going to replace it for w. And what I like to do is to put that substituted value in parentheses. So now I have negative 10 minus 4 equals negative 6. And you'll often see me put a little question mark above my equal sign, because I'm asking myself, is this expression on the left, negative 10 minus 4, equal to negative 6? Now, since we just got through with operations with rational numbers, and by rational numbers I mean integers and fractions and decimals, I don't want us to forget those rules, because here's an example of where that rule is going to be very helpful to us, because I can see right away I have a negative number and I'm subtracting from it. So to me, it would seem obvious that KCO is going to be a really helpful tool to me. So I'm going to do KCO, and the negative 10 minus 4 is going to become negative 10 plus negative 4. So I'm doing a little bit of work off to the side here. I'm taking this and I'm just swinging it up there so I can continue with getting this in a more user-friendly format. And since I've taken the trouble to convert from subtraction to addition with KCO, it would seem the next logical step is to set up my scoreboard. So what I'm essentially adding is negative 10 and negative 4. I know I'm going to get a negative number, and I know because they're in the same column, I'm simply going to add those. So by the time I'm done, I'm going to have negative 14, because that's what negative 10 plus negative 4 is equal to negative 6. Now that makes no sense. So since it's not a balanced result, it proves for us that w equals negative 10 is not a solution, because negative 14 does not equal negative 6. So the way we're going to state this final answer is not a solution, we're actually going to write out that the value that's provided for us to test is not a solution, and our proof is going to be -14 equal or does not equal -6. So that's how I want us to be in the habit of writing these final answers, to state yes it is or no it's not, as is the case here, and then the bottom line proof that goes with it. So I want to try that one more time, and then you'll see there are two more problems for you to finish on the bottom on your own, okay? And again, when you get to doing the independent practice, if you don't understand something, you have a couple of choices. You can either watch the video again, or parts of the video that might be relevant for you to understand the concept more. Or you can look back at the notes that you have filled in already. Or you can come and see me before school for some further explanation. So let's try this again. We have an equation, n over 4, we think of that as n divided by 4, minus 7 equals 5. We're given a value of n equals 8 as a potential solution. So what we want to know, is that a solution, or is that the value that makes that equation true? So we will start again by rewriting the equation. N over 4 minus 7 equals 5. And then we're going to take our given value. So remind you, where I'm taking this from is I'm substituting the value in. So I rewrote the equation because it's always a good starting point. Now I'm substituting the value in. So I'm going to substitute n equals 8 in for n there. So I'm going to say 8 over 4, 8 divided by 4 minus 7. Does that equal 5? And again, you don't need to put the question mark there, but I like to put it because it's not a true statement as yet. So here we have some order of operations, don't we? Here I have GEMDAS. So I'm just going to make a note of that. I have GEMDAS. Because I have two operations going on. I have division and I have subtraction. And GEMDAS says I'm going to do the division as step number 1. And I'm going to do the subtraction as step number 2, because division comes before subtracting, okay? So that's the order that we're going to take. So since I'm running out of room vertically, I'm just going to take this and go up here and rewrite it. 8 over 4, 8 divided by 4, minus 7. Does that equal 5? So let's go through and do our division. Let's see. So I'm going to do step number 1. Is 8, what is 8 divided by 4? That's 2. And then I'll rewrite everything else. Minus 7, does that equal 5? And now I'll move on to the subtraction. Well, again, I don't like subtraction, so I'm going to take liberties to use KCO. So look at all the extra space I'm taking. I know some of you guys are afraid of stretching out the space for your work, but take liberties to do so, okay? So KCO, I'm going to turn 2 minus 7 into 2 plus -7. And I'm going to set up my scoreboard. And my scoreboard is going to tell me that the 2 being positive goes on the right, the 7 being negative goes on the left. And because the numbers are on separate sides, as we should know by now with all the practice we've done, our answer will be negative. And it will be based on it being the negative of 7 minus 2. So my answer here is -5. So that is essentially saying that 2 minus 7 is -5. Is it equal to 5? Again, just by chance, it is not a solution. So our answer, we say not a solution. And the reason for that is, or the proof of that is because -5 does not equal +5. So you have 2 more examples to work through on your own. And again, you're going to stick to GEMDAS. So you're going to substitute your given value, in this case x equals 12 in for x, and you're going to follow order operations. So you'll do what's in the parentheses before you multiply, and you'll see if you get a true result. For the last one, you will follow order operations. Now, this one's a little bit tricky, so be careful when you do it. There's a value of a on each side of the equation. So wherever a is, when you get to substituting in, you're going to need to put that value of 16 in and then follow order operations. So on the left side, it looks like you'll have to multiply. On the right side, you'll have to do parentheses before you multiply. So take your time with those. And the first thing we'll do when we come to class tomorrow is check in on those answers, and then we'll do more practice. So that's it for today.